Hello everyone. Let's do some curve sketching in this lesson. We are not actually going to sketch a curve. We are just going to identify the correct function from the graph by using point plotting or symmetry or asymptotes. Okay, so we are not going to sketch, we are just going to identify the graph from the function or function from the graph. It is just like chapter 1 section 1 point plotting topic. We will be doing generally point plotting. So first let's try to identify some key points for each graph and analyze the graph first. In the first graph, let's talk about domain. We see graph everywhere except these two vertical asymptotes, so we can say it's all real numbers except -2 and +2. Let's talk about x-intercepts. It is the point where function is crossing the x-axis, which is -3 and +3. -3, 0 and +3, 0 are x-intercepts. Y-intercept, it is the point where function is crossing the y-axis, which is 4.5 maybe. So 0, 4.5 is the y-intercept. Vertical asymptote, it's the invisible vertical lines that function is approaching, which are x equals -2 and 2. Horizontal asymptote, it's the horizontal line that function is approaching, which is passing through y equals 2. Slant asymptote, an inclined line that function is approaching, which is none. We don't have a slant asymptote. Let's identify increasing and decreasing intervals. This part of the function is decreasing. This part is also decreasing. So decreasing interval is from -infinity to -2 union between those two, from -2 to 0. And the other side of the graph is increasing. This part and that part are increasing from 0 to 2 and 2 to infinity. And let's talk about concavity. I see this part is opening down. This part is also opening down, meaning those two are convex intervals from -infinity to -2 union 2 to infinity. And this part is opening up, which is concave between -2 and 2. I don't have a point of inflection, even though function changes its concavity from convex to concave, concave to convex, because the function is undefined at 2 and -2. There is no point of inflection. What else? We can talk about critical value. It's where the graph, the derivative is 0 or undefined. Derivative is 0 here at x equals 0. We can draw a horizontal tangent line here. So derivative is 0 here. We have a critical value at x equals 0. And we can also say there is a local minimum point here. And I think that's it for the first graph. For the second graph, let's do the same, identify everything that we did in the first graph. Domain, all real numbers except the vertical asymptote, which is 2. X-intercept, there is no point that function is crossing the x-axis. Y-intercept, this is the point where function is crossing on the y-axis, which is 0, -2. Vertical asymptote, it's passing through x equals 2. Horizontal asymptote, none. Slant asymptote, we have an inclined asymptote here. So we can write its equation by picking 2 points from the line and writing the equation of the line. And increasing, decreasing intervals, this part is increasing, that part is also increasing. So from -infinity till 0, and from what number we have here, let's say 4, from 4 to infinity function is increasing, and the other regions function is decreasing, 0 to 2 and 2 to 4 it is decreasing. And I see a minimum point here at x equals 4, a maximum point here at x equals 0. So since we have local extrema, we have critical values at these 2 points. And about concavity, this part is convex, that part is concave. So -infinity till 2 is convex region, from 2 to infinity is concave region. Concavity changes, but that point is not point of inflection because it's undefined. I think that's it. So it's important for us to be able to analyze the graph. When we look at the graph, we should be able to tell everything about the graph in order to be able to identify the function from the graph. This is necessary. Okay, let's take a look at some questions and see how to identify functions from the graphs. Okay, first graph, exercise 15. Which of the following is the function? So I'm gonna do point plotting. They are all absolute values. There's nothing I can eliminate. So I'm just gonna do point plotting. I see a clear point here, 0, 3. So let's use 0, 3 in the options. 0 makes the result 3. So A may be true. Option B, 0 makes the result 6. So B is false. 0 makes the result 3. D may be true. 0 makes the result 1.5, so C is not. So I eliminated 2 options. I have 2 more options, which means I need to try 1 more point. I am looking for another clear point on the graph. This one, for example. 1, 1 is also clear. Let's try 1 for x. When x is 1, 2 times 1, 2 minus 3, negative 1, which is 1. So it works. Option A is true for this point. Option D, when I put 1 back, I'm gonna get 2 plus 3, 5, which is false. I'm supposed to get 1. So option A is true here. Okay. It is easy, simple by point plotting. 2024 second attempt ministry question. Let's identify the graph, function from the graph. So when I look at the graph, I see an even graph. The right side of y-axis is identical the left side of the y-axis, so I have an even graph. Option A is not even. Option D is not even. Option B is parabola. Our graph is not parabola. So without using any point plotting, I can identify the function from the graph by using even, by using the type of the function. That's it. So we don't always have to use point plotting. We can also use intercepts, symmetry, asymptotes, okay, to identify the function. Okay. Exercise question and a ministry question. Which one is true? I see the same types of functions actually. They're all rational. We all have the same type. So it is not even. The asymptote, the vertical asymptote is x equals 4. Here 4, here 4, here 4, here is not. So I can use point plotting after this point. There's nothing else I can do. Let me pick a point from the graph. I see this point, it is clear, which is 2, negative 2. I'm going to use 2, negative 2 in the options and see which one works. Option C, for example, when I insert 2, what will I get as a result? 2 squared 4, 4 times 3, 12, minus 5 times 2, 10, 12 minus 10, 2, plus 3, 5, over 2 times 3, 6, 6 minus 12 minus 6, which is not negative 2, so that's false. Option B, let's try 2 squared 4, 6 times 2, negative 12, positive 12 will cancel each other. It's 4 at the top, 2 minus 4, negative 2 at the bottom, which gives me negative 2. So when I insert 2 for x, I get negative 2 for y. It seems option B is true. Okay, one last question. I see an even function here. They are all even, so it will not help me to solve the question. Let's try a point. I see a clear point here, which is 0, 1. Let's use 0 in the options and see what the result is. 0 gives me -1, false. Option A is false. Insert 0 for x, it will give me -1, which is false. Insert 0 for x, it will give me 1, which may be true. Give 0 for x, it gives me 1, it may be true. So I eliminated two options. I get two other options to eliminate. So what else can I use? I see the same asymptotes in both of them, and I didn't look at the intercepts, so let's take a look at the intercepts. I don't see an x-intercept here. No x-intercept. So which option doesn't have an intercept? Option D. If there is an what is x-intercept in option D? Let y be 0. 0 is x squared over 1 minus x squared. 0 is x squared, then x is 0 is the x-intercept, which is false. I am not supposed to have an intercept. Try option C. 0 equals x squared plus 1 over 1 minus x squared. 0 is x squared plus 1, so there is no x in option C. I don't have an x-intercept in option C. This is no x-intercept, so this is the correct answer then. So this is the way of identifying the functions from the graphs by using intercepts, symmetry, asymptotes, point plotting,